Now we're still on number 3. Y equals AT squared plus BT plus C is always a parabola. So your quadratic model is always going to give you the graph of a parabola. So the curve, and this is going to be familiar to you because most of you, at least those of you who handed in the project-related questions, and most people did. If you didn't, you really need to do that. It's only worth half credit now, but half credit's better than none. Okay, so anyhow, the curve for the actual flow is going to look much like this. Okay, it's probably not going to be as steep as this. I didn't draw it very well, but you get the idea. So the actual flow would go from some initial time, which we'll call t sub 0, and that depends on how you made your marks when you started, how many marks, how many tick marks you made, how many check marks you made, and where you made the check marks. So this T0 will be different for different people, but for your observation, this is where the actual graph of the flow starts, and it stops at the vertex of a parabola, at least according to the model. Now there's some little anomalies related to surface tension and a few other things that I probably haven't even thought about, where that really doesn't quite give you where the flow stops, but we're not going to worry about that. Now, the parabola itself keeps going up. But of course, the flow doesn't reverse itself. The depth of the water doesn't start increasing again. So at this point, the the model no longer applies. This function no longer is the function for the model. And the way we say that is between this initial mark, the initial check mark that you made, the first mark I called, between here and the point where the flow stops, that's the domain of this function. Okay, now it's a parabola. The parabola could be identified for any real number. There's no restriction on the domain of the parabola, the domain being the numbers that you can put in and get a meaningful result. Okay, so you put any number in for t and get a meaningful, or you get a value of y, which would be meaningful in terms of graphing, but it wouldn't be meaningful in terms of the flow that we observed. So the domain for the flow would only be from whatever your T naught is, the point where, at the time when you made your first mark, up to the point where the flow stops, which is presumably at the vertex of the parabola. So the domain would be all T values relevant to the, I should qualify this for the flow. Okay, well, we timed the flow between T naught and Tf, where T sub f is the time when the flow stops. So the domain is the closed interval from T naught to Tf, which could be written T naught less than or equal to T less than or equal to T sub f. The range is all the y values. Now I don't remember what the y values were. I did the measurements and I sent those out. Maybe 0 less than or equal to y less than or equal to 148, but it might not have been 0. And that would be the closed y interval 0, 148, or whatever those numbers happen to be. So this answers the question about the domain and range, and also reminds you of what domain and range are. People seem to kind of know, and maybe gives you a little bit of an idea of why domain and range are important concepts.